So, can I start?
Yes, please.
Thank you. Hi, my name is Kzk Knmt. I work as a computer vision engineer in Japan. I am delighted to receive eighth place, and have the opportunity to present my solution today. Actually, I'm not very good at English. It's nice to meet you. I'll explain my solution overview of Child Mind Institute problematic internet use. Today's agenda. First, about my background. Second, summary of my solution. Third, feature selection and feature engineering. Fourth, training and validation methods. Fifth, imputing missing values to improve CB score. Sixth, solution overview. First, my background. I have a master's degree in computer science. Now I work as a computer vision engineer at a life sciences company in Japan. This is a summary of my solution. First, I selected features using null importance to improve robustness. I'll explain null importance in detail later. I built ensemble models consisting of RightGBM, XGBoost, and CatBoost trained on 3 types of features. I also built 5-fold cross-validation with 3 different sheets to stabilize QWK metric. I optimized the threshold of regression values for hard labeling targets. Lastly, I imputed missing numerical values using iterative imputer to improve the QWK metric. This is an overview of feature selection and engineering. I trained models on 3 types features. I called their features 1, feature 2, feature 3. I selected the features using null importance to improve robustness against noisy data. And age and computer internet hours day are numerical variables in train.csv. And they were consistently high importance across all models trained on 3 types of features. First, I'll explain null importance. First, the importance of features is calculated by shuffling the target variable SII and 10,000 times. Second step, the actual importance of features is calculated. And third step, a percentile threshold is set for the randomized importance, and features then the percentile are selected, not selected. Fourth, reduce as many features as possible while maintaining the CB score of the QWK metric. Finally, I applied null importance to all 3 types of features. Next, I'll explain features. This is the importance plot of features 1. The number of features 1 is 14. Features 1 consists of numerical variables in train.csv. As shown in the figure, age and computer internet hours day are the first and second highest importance. Next, this is the importance plot of feature 2. The number of feature 2 is 13. Feature 2 consists of numerical variables in train.csv, descriptive features of actigraphy data, such as mean, standard deviation, min-max, and quantile statistics values. I also add actigraphy data, calculating absolute values of x, y, z, and angle z, and computing Euclidean norm of x, y, and z. It's also age and computer internet hours day are the first and second highest importance. Last, this is the importance plot of feature 3. The number of feature 3 is 40. Feature 3 consists of numerical variables in train.csv. Feature engineering refers to many public kernels and descriptive features of actigraphy data, and one more descriptive features of actigraphy data divided into 4 time periods based on time of data. It's also age and computer internet hours day are first and third highest importance. Next, I'll show CB score of models on 3 types of features. In this table, I calculate the CB score of the right GBM regressor before and after feature selection using null importance. The CB score is a QWK metric applied with threshold optimization to the regression values. I got an improved score overall, decreasing noisy features. Next, this is an overview of training and validation methods. First, I built ensemble models blending right GBM, XGBoost, and CatBoost regressor. I determined the blending weights to maximize the CB score. I built 5-fold stratified cross-validation with 3 different sheets to stabilize the QWK metric. I optimized the threshold of regression values for hard labeling targets based on all validation predictions using the Nelda-Mead method. Lastly, I tuned hyperparameters of models with Optuna for each 5-fold stratified cross-validation. Next, I'll show the training and validation pipeline. First, you prepare the training data. Second step, building 5 stratified CB with 3 different sheets, and training and tuning hyperparameters. Third step, you optimize the threshold across all validation predictions using Nelda-Mead. And lastly, I calculated the optimized QWK metric as a CB score and create the submission kernel. Here is a table of weights and CB score of models. I conducted a grid search with a step size of 0.1 for ensemble weights. Finally, I determined the blending weights to maximize the CB score. And as a result, ensemble model had highest CB score in this table weights. Next, I'll explain imputation methods. I imputed missing numerical values in train.csv using iterative imputer to improve the CB score. And I trained the imputer on all numerical variables in train.csv using 5 stratified cross-validation with 3 different sheets like other models. I'll show the CB score table imputing missing values. First, I calculated the CB score of the right GBM regressor before and after imputing missing numerical values using iterative imputer. The CB score is a QWK metric applied with threshold optimization to the regression values. And as shown in the table, It might be the CB score decreased only for features 3 because missing values were imputed for the numerical variables, which are not included in features 1, feature 2. Those features are here. However, I'm not sure about the reason for the decrease in the CB score, so I decided to adapt the iterative imputer for all types of features. Lastly, I'll explain the solution overview. There are 3 main keys to the solution. First, to stabilize the CB score of the QWK metric, I built a 5-fold stratified cross-validation with 3 different sheets and optimized the hard labeling threshold on all validation predictions. Second, to enhance robustness against noisy data and features that don't contribute to predictions, I selected features using null importance. Third, to improve the CB score of the QWK metric, I imputed missing numerical values using iterative imputer. Lastly, I'd like to say this competition provided an excellent opportunity for my practical data analysis skills by working with raw and unprocessed data. It was fun. I couldn't expect result praise because this competition was expected to significant shakeups. So I could continue to concentrate on task until the end. Thank you.